Everyone, Brightbone here, and I'm back with another video. And today we're going to talk about how to build a cybersecurity lab or range. I've built one here that I've used for all the videos you've seen on my channel. It's extremely important that you try to map what a normal environment would be while still having your tooling. In particular, we want to have something that looks like a modern organization. So what I built was similar to a modern organization, just a very cut down version of it. So in my lab, we have VMware on a Supermicro server. I just have ESXi running on a Supermicro server. Now that Supermicro server is pretty powerful though. I have 128 gigs of RAM in it, just so I can support all of the different types of servers and things necessary. It has dual Xeons as well. You can get them on eBay for fairly decent price, but just realize if you want to stand up your own server for your own range, this is my recommended method. A lot of people try to use cloud for this. I find the spin up, spin down process to be a little bit taxing, and sometimes it doesn't work the same every time, but feel free to use cloud for the same kind of thing. You can use Azure or AWS. So what I have is I have a pfSense firewall that all of my range sits behind. And then I have a vSwitch, ESXi vSwitch, that connects everything inside of ESXi. Now, my server connects to a switch that supports VLAN tagging. So if I can do VLAN tagging, I can move things in and out, whether they be physical or virtual, into this vSwitch LAN, right? So I have VLAN 500, which is my hack lab. Everything else in my house here is different VLAN numbers, for one for my office, one for my son's stuff. But we have all sorts of different VLANs that we use for different things. Each one of those also has its own wireless SSID that is separated. So on the vSwitch, everything in here is in VLAN 500. I have 3 Linux hosts. I have one that runs Zeek and Suricata, and that one is in promiscuous mode, so it can see all the traffic flowing through this vSwitch. I have one that runs the Elastic SIEM, that runs a version of Docker Elk, and that hasn't been customized very much, to be honest. It's just a standard Elastic setup that gives me the ability to easily spin down and spin back up and change versions if I need to. And it's a lab. I don't have to worry about log retention here, right? It's all just for research. And then just for ease of use, I run Kali Linux. I could run Debian. I mean, I could run a bunch of, handcrafted tools as well, or Warberry Pi, or all sorts of different things. But I find Kali's just easy. All the tools are pre-installed that I would need in most cases for attacking from a Linux perspective. I also have a whole bunch of different Windows servers and workstations. So I have 2 domain controllers, a PDC, and a backup. I could probably get away with 1. I also have a Windows file server. That Windows file server is a certificate authority. It's to simulate, certificate type attacks, things like certify.exe or certify. You can run against the certificate authority. It's also just a standard SMB server as well, so it serves out file shares. So in some of the demos you've probably seen when we did, like responder style stuff, the file server responding. It runs DFS as well, so distributed file system, across one of the domain controllers. Not really all that necessary. You don't have to go to that in depth. Windows workstations. I have one that I use specifically for more of the threat hunting style, and one that is just consistently a victim. Now you can run multiple here, but one of these is consistently a victim, and one is consistently where I do analysis work. One of the great things about having a range like this is if I want to use real malware samples or real anything, I can just load it in here fairly safely. And because it's behind this pfSense firewall, I can't get to the rest of my network. So I can use LiveFire in here and not worry about anything being infected except these few VMs, and they're all snapshotted. So I can just, revert the snapshot if I need to. So let's take a look at VMware and what I've done here. So you can see here are my active VMs. I have my DC, my file server, my pfSense gateway, my Hunter workstation. This is a Windows 10 workstation. This is like my victim workstation, Windows 10 host 2. My other domain controller, Kali Linux, Elastic SIEM, Suricata, and that's the Suricata and Zeek. And then I have an open VPN here. If I need to remote into my lab, I can remote into the lab. So if we take a look at the SIEM, we can see it's just a simple Ubuntu system. I've set up SSH on it here, but I used a project called Docker Elk, and you can just go to GitHub, get this, and customize it a little bit. Inside Docker Elk, you have Elasticsearch, you have Kibana, and you have Logstash. Now, each of those have configs in each of these folders. So if I go into Elasticsearch, here, you can see the config file. So if I cat out config, actually that's a directory. So I need to go into the directory. And then I cat out the Elasticsearch YAML. And you can see this is the configuration for the Elasticsearch backend, right? So this is the Elastic proper, not Kibana, not what you work from, but we have just a network host, and you see the licenses trial, also have XPack security enabled true, because what that does is that allows me to download the default rules and have those in the SIEM. Now, each one of your configurations has just a little bit of difference, but there is also a main setup file. So if we go back up a couple directories here, and you see setup here, you have your Docker file, your entrypoint.sh, your helpers.sh, and your roles. So you can change most everything within the Docker files from here. There's also, in the directory, there's a very important file called the env file. So if you do ls-la long, you can see it starts with a dot. So it's kind of hidden, right? It's a .env file. So if I cat out the .env file, this is my environment file for Docker. So this gives me the Elastic password that I've set, the Logstash password, and the Kibana system password. Now I just leave these the defaults. It's a lab. I don't care. What's going to happen, right? You can use the change me, or you can set them here if you're worried about that. I also don't do HTTPS on Elastic in this lab because it's a lab. You know, it requires extra work to do that, right? So I just use HTTP for my pushes for FileBeat and for Winlogbeat, which we'll take a look at that here in a second. But if we do sudo docker ps here, you can see I have my 3 pieces running in Docker. They've been up 6 days. Here's Docker Elk Logstash, Docker Elk Kibana, and Docker Elk Elasticsearch. So that provides the entirety of the SIEM backend on one workstation, virtualized here in my lab. Now, I did give it quite a bit of RAM and quite a bit of storage space, right? I gave it 16 gigs of RAM and about 200 gigs of storage space, just so I'm not constantly having to roll it over. But it does work, works like a champ. Been using it now for quite a while. So let's take a look at our other backend pieces. So if we jump over here to ESXi, and we'll take a look at Suricata. So Suricata is my VM that does Zeek and Suricata. So if I pop this open, I'll have to sign in here. We can see here is FileBeats just running, right? I don't have it set up as a service because it's the newest version of FileBeats. There wasn't a package for it. So I just set it to run and I put it as a background job. If I hit enter here, I get my command line back. If I go jobs, I can see I've got FileBeat-E running, right? Now, if we take a look at this file, we'll cat out the FileBeat.yaml. This is the configuration file for it. So if you take a look up here, you're going to see, actually, let's just get out of root and it'll colorize so it looks a little better. That way you can see the configuration changes. So we'll exit the root shell, and then we'll go here, and then we'll cat it out so it'll colorize. Got a sudo for it now. Okay. And if we scroll up, a little bit of weird things going on here because of this being nested in another window. All right, it's not going to work. We'll just do this then. We'll just open it in Nano. Nano filebeat.yaml. And of course, I need to sudo. Okay, we can see for our FileBeat's inputs here, what we have is we have the type is file stream. So that's the newer types that you would use for Elastic 8. It comes in as a file stream, and like a data stream instead of being just a flat file. And then we have paths here. So I have var log Suricata. So I'm grabbing all of the logs from Suricata in the star.log file here. And then I've got Zeek. So the current Zeek logs are being set up and sent over to the Elastic SIEM. These two, you have to set up Suricata to log out JSON, right? And you have to set up Zeek to do the same. But there are good articles out there that you can set it up where it can send over to Elastic, no problem. Pretty easy to do. Now, we didn't really change anything here on the modules. This is the same as normal, just path config modules D. And then not much else changes in FileBeats here with the exception of our protocol and our host. So our host, this is our Elastic host 203. We're using HTTP and we're just using the default Elastic change me password, right? Don't care, it's a lab. And that's all I had to do to get these two to log over to Elastic. Now, when you are setting this up, you're gonna run FileBeat setup -e, not FileBeat -e, but you type in the word setup. And what that does is it reaches out to Kibana and it loads all the dashboards that you would want for these two things. So if I pop over here to Elastic SIEM, you can see I've got my FileBeat Suricata events overview here. This is my events, and then I've got my alerts. I didn't have to configure any of this, it's built in. It knows, oh, you're gonna want these alerts for Suricata. So you load the modules, you do module Suricata, you do module Zeek, and then you do FileBeat setup -e, and it will set it all up for you. So if I go over here into my dashboards, I can now search for Zeek as well. Actually, wrong search box. And see, I have the FileBeat Zeek overview. So this gives me all of my Zeek hunting stuff. So if I need to see if Zeek's going to catch something or write a Zeek rule, I can do that. Same thing with Suricata. So that's the Linux pieces, right? We've got the Elastic SIEM, we've got Zeek and Suricata on the other piece, and then we've got Kali Linux, which that's pretty self-explanatory. Now on Windows, we're using Winlogbeat. And Winlogbeat in the default fashion without HTTPS, really, really easy to configure. So what you're looking at here is my winlogbeat.yaml file that is located in my Winlogbeat's agent. Now, I didn't upgrade this to the newest version, but 7.1.17.3 is fine, and you don't have to stay on the exact same agent version as the SIEM, right? An older version of FileBeat and Winlogbeat will push to a newer version of Elastic. So I've got my Winlogbeat YAML here. This is the install service winlogbeat.ps1. So you have to run this PowerShell file to install the Winlogbeat after you configure your YAML file. Now you only have to do that one time. So if you make any changes, you don't have to come back and reinstall it every time. You just restart the service. So notice I'm grabbing the application, system, security, Microsoft Windows Sysmon, PowerShell, and this is regular PowerShell, not PowerShell operational, and then PowerShell operational, 4103, 4104, 4105, 4106, right? I'm grabbing these and sending them over to SIEM. If I needed to add a new store, I just do -name and I give it the channel of the event store, right? And this is my Windows host. This isn't my Active Directory domain controller. It has a few different little settings in here, but most of this is the same. I also can do weth-wec. So if I wanted to do Windows Event Forwarding, Windows Event Collection, I can grab the forwarded events store on that whichever server is the WEF server, and then I can forward those onto SIEM as well. Very simple output configuration here, just the IP, the port, the username, and the password, and then allow older versions as true. And that's it for that particular setup on the Windows host. Now, if we take a look here at ESXi, I'll hide these other VMs. Just powered on VMs. The setup of Kali Linux is pretty straightforward. You'll need to download the version of Kali Linux that you like. Now, my version of Kali Linux, I've set up RDP on it. And RDP is pretty useful, right? Especially when you want to show the GUI of Kali Linux without just using the command line. SSH is enabled by default, but sometimes you want the GUI, right? You want to see the GUI tool. So setting up RDP is fairly straightforward on Kali Linux. That's what I usually use just for demo purposes. In day-to-day work, SSH is fine. Or if you're running it locally, you obviously have the GUI. My Hunter workstation is outfitted with several different tools. I have some threat hunting utilities on there like Velociraptor. Velociraptor, fantastic threat hunting tool. Velociraptor is installed on all of the Windows devices. So if I need to do some forensic things like grab prefetch, shim cache, things like that, I can just go to the Velociraptor console and drag those in. Well, the Velociraptor server runs on the Windows 2016 file server. So with this lab, I've been able to do some pretty advanced things, right? Another thing I always set up is over here in my config file, which I use Royal. I've been able to do CyberChef, regexer, which is a good place for regexing, and then also the network intrusion detection system, shortcuts, VMware shortcut, my work Mac. All of my stuff is over here in my hack lab. I just choose what I want to show, right? And it pops up in tabs here. So very simple overall. There's a lot of work in building one of these labs and keeping it going, but once you get it to where it is, stable and what you want it to be, it's quite easy to maintain, right? This single server, I really don't touch it that often. Occasionally the SIEM will get full or something weird will happen. So I just log in, shut down the Docker containers, purge everything, and stand it right back up. And then it'll start working after about 30 minutes or so. Suricata, I haven't really had to do anything. I did have to go in and turn off a lot of the default rules because they are very loud and they'll create a lot of stress in a lab environment. So I just turned off some of the louder rules that aren't any really useful information in them anyway. Zeek, I haven't really had to do much. Zeek, standard setup for Zeek, typical Zeek control for setup, logging out to JSON. Not as loud as I thought it was going to be. One very important thing that you want to remember when setting this lab up for that Linux host that's doing the network traffic analysis, though, is in your vSwitch, you want to make sure that the host for that is set in promiscuous mode and your vSwitch allows promiscuous mode. Otherwise, you're not going to be able to see the traffic for anything else. So if I go over here to vNIC 0, I should be able to, let's go edit settings. It's not in here. Let's go into vSwitch 0. We'll go edit settings here. And under security, promiscuous mode accept, MAC address changes accept, and force transmits accept. This is more like a real LAN, right? We want to make sure that especially promiscuous mode accept is on, or you won't be able to set up a VM to detect things the same way as a network intrusion detection system would, right? I don't have to deal with tap or span because I did this, right? Very simple overall. Then you can see all the different hosts are connected to the different VLANs here, specifically my hack lab VLAN. This is my lab over here. So I've got a lot of stuff that's stood up in here that's shut down, but I've also got several hosts that are active, right? And if I want to add something or spin it up, I just put it in that VLAN ID and it lands behind this pfSense gateway. And then I NAT through the pfSense gateway to reach in when I'm connected to my LAN. And I can also open VPN into that and give myself free reign reachability. On Mac, there's a client called TunnelBlick. You can also use the default built-in Mac networking to do an OpenVPN standard setup. Now, OpenVPN, if you're going to do that, you want to make sure you secure this pretty well because you are giving the outside world access to your lab. So set up two-factor there. Don't leave it exposed to the web with the default settings or do anything silly there. But yeah, it works very well. This setup has worked for all the videos that you've seen me do. And I'm hoping to expand it as necessary. There are times where I need to add new things for Windows servers. There are times where I need to add new Linux servers for testing of exploitation and things like that. But overall, it's been fairly flexible. So one small server, one switch that supports VLAN IDs, making sure that your wireless in your home supports VLAN IDs. That's really helpful as well. And then just standing up exactly what you need for your lab. And that's it for this particular video. Thank you very much. I wanted to, kind of celebrate this milestone. We've reached over 1,000 subscribers already. So that is a big deal. And being able to do that is fantastic. We're hoping to grow the channel more and more. If you have interest in seeing any particular type videos, let me know. And we'll be glad to stand those up for you, get them going. But yeah, thanks to all of my subscribers and keep those numbers coming in. We'll keep expanding the channel. Thank you very much.